Up to this point, we have added and subtracted matrices and multiplied by a scalar. So just very quickly, let's have a super fast review. When I am adding or subtracting matrices, they have to have the same dimensions. And it's pretty straightforward. You're just going to add straight across or, subtract straight across. Sometimes you can multiply by a scalar, which means you're basically going to multiply, in this case, everything by 12. It's like you're distributing the 12. But then when I actually have two matrices multiplied together, things get a little bit different. So let's write a couple sentences that'll begin to make some sense of this. And again, quick review. When adding or subtracting matrices, the dimensions must be the same. Dimensions must be the same. Okay? But when multiplying matrices, things get really different. And actually, this is going to be really wordy, but then when you see it in an example, you'll understand. So when multiplying matrices, the number is going to be a long sentence. The number of columns of the first matrix must equal the number of rows of the second matrix. It'll make sense in a minute. Number of rows of the second matrix. Okay, so let's let that sink in for just a moment, that I have to have the same number of columns in the first matrix as I have rows in the second matrix. And it's always good to know that every time I talk about the dimensions or the order, there's another word we use, when I talk about the dimensions or the order, I'm always going to have rows and then I'm going to have columns. Always rows, then columns. So let's write a few things out. I can multiply this matrix times this matrix. I can. Now, again, when you're looking at matrix multiplication, don't be thinking of addition or subtraction. Don't look at this and say, oh, they're not the same dimensions. That's irrelevant. First time I saw matrix multiplication, I thought that's the weirdest thing and it's ridiculous. But then when I saw a word problem, I realized how practical it really is. So let's do it. I can multiply these, and here's the reason I can. This matrix right here has 2 rows and 3 columns. All right, so let's just pause that thought and read the sentence again. The number of columns of the first matrix, okay, 3 columns, must equal the number of rows of the second matrix. Well, the second matrix has 3 rows and 1 column. And just so I'm kind of clear on what I'm multiplying here, instead of putting another X, I'm going to put a dot because sometimes that means multiplication as well. So what I really have was rows and columns, rows and columns, and the columns here, COL, match the rows here, and that's exactly what they wanted. So because these 2 middle numbers are the same, I can multiply them. So we're going to start without multiplying them. We're just going to figure out if you can or can't, because that's the tricky part. And then we get to actually multiplying them. So we're going to spend the front page of these notes just trying to determine if you can or if you can't multiply them. So in this case, I can. And let's go a little bit further. If I was to multiply these, and we're not going to worry about what that process looks like yet. We'll get to that in a minute. If we were to multiply it, we would end up with a 2 by 1 matrix. Trust me on that, we would. So if we had a 2 by 3 times a 3 by 1, then because these are the same, the columns of the first and the rows of the second, they match up, I'd have a 2 by 1 matrix. All right, let's go to this one. I cannot multiply these. Actually, they're the same matrices, they're just backwards, which tells me that matrix multiplication is not commutative. In other words, you can't change the order. So this is a 3 by 1 matrix, 3 rows, 1 column. And this is a 2 by 3 matrix. And I always look at the columns of the first one and the rows of the second. In other words, these middle numbers right here. And because these are not the same, I can't do it. So we're not even going to say it equals whatever, because it doesn't. I can't do it. I can't multiply those together. All right, so what we need to do is determine if I can perform any of these operations with what I'm given down here. So again, we are not multiplying the matrix, one matrix times another. We're not multiplying the matrices together. We are determining if you can or not. We don't know the answer. we never got an answer here. We just determined the dimensions of the answer, okay? We'll get the answer in the next video. So first thing I want to do is determine if I can multiply A times C. So what I need to do is look at the dimensions and see if it works. So A, C. Now again, you've seen this before, but if I have two letters crammed together and they represent something, then I'm multiplying them. So even though I don't have a multiplication symbol in the middle, this means multiplication. And it's kind of obvious when it's multiplication and when it's not. So yeah, that's fairly obvious. Okay, so AC. A is a 4x3 matrix, and I'm looking right here, 4 rows, 3 columns, and I'm going to multiply it with C, which is a 3-row, 1-column matrix, 3x1, and then I say, oh, well, see, they do match up, so determine which of the operations are possible, and this one's a yes, and if they are possible, determine the dimensions of the answer. So if I multiplied those, I would say it equals a 4x1. Now, we haven't multiplied them, we just determined the dimensions, okay? Just throwing that out there. So let's move on. A times B. These will start going pretty fast after a while. You'll get a little bit bored with it, which is actually good because then you'll know what's going on. So A is a 4x3, B is a 1-row, 2-column matrix. Because of that, you can't do this one. I'm just going to put no. All right, so I am going to just go ahead and move forward in these. I recommend that you mute this video and start trying these on your own. And I do want to warn you about these two, which aren't tricky, but they are different than what we're learning. You've already learned them. I just want you to be cautious, okay? So I'm going to keep talking, mute this, and try it on your own. Just kind of glance up at the video from time to time, making sure you're good. So 4x3 multiplies by a D, which is a 2x4, 2x4, and because 3 and 2 aren't the same, this one's a no. Okay, all right, ED. E is 2 rows, 2 columns, so we have a 2x2. And we're going to multiply it by D, which is a 2, you already know the answer at this point, 2-row, 4-column matrix, 2x4. We're going to look at those and say, oh, they are the same. This one's a yes, and because it's a yes, I could write the word yes, but I also want to tell what the dimensions would be if I multiplied them, and it would be a 2x4. Okay, DE, let's see. D is 2x4, 2 rows, 4 columns. E is a 2x2, and there's lots of 2's here, but that's irrelevant. If those don't match up, it's a no. The ones in the middle, if they don't match up, that's a no. All right, CB. C is 3 rows, 1 column, so 1, 2, 3 rows, 1 column. B is 1 row, 2 columns, so times 1x2. 1 and 1, they match up. This one's a yes. I'm not going to write yes. I'm actually going to say what it would be. If I multiplied them, I'd have a 3x2. 3x2. Okay, let's keep going. CF. C is a 3x1. F is a 3x1. And because I know they're the same, but the dimensions of both are the same, but these in the middle are not, and so therefore this one's a no. However, if I have C plus F, I have a 3x1 plus a 3x1, and you've done this. When I'm adding, the dimensions must be the same, and it is. So if I added a 3x1 matrix to a 3x1 matrix, I would have a 3x1 matrix. And I know this looks like a math problem where you do 3 times 1 plus 3 times 1. That's not it. We're talking about dimensions, okay? All right, moving right along. B is a 1x2, and D is a 2x4. And because I have the 2 and the 2 in the middle, this one's a yes, so it's a 1x4. 1x4. We take the first one and the last one, the rows of the first and the columns of the last. All right, BE is a 1x2, and then we're going to multiply it by a 2x2. And because of that, we are going to have a 1x2. So I don't know if I've explained this well enough, but I do want to clarify at this point that whenever you can do it, what you're really doing is canceling out those middle ones. So 4x1. These cancel. 2x4. These cancel. 3x2. These cancel. 1x4. These cancel. 1x2. All right, BA is a 1 by 2. We're going to multiply it by a 4 by 3. And no, we're not going to do that because these two do not match up. That one's a no. And final one, a plus c. We have a 4 by 3, and we're going to add it to a 3 by 1. And I do want to point out that we are adding, not multiplying. So you might say, oh, the 3's are the same. This one's still a no because we are adding.